Here's our first example. We have a bunch of radicals to evaluate. Okay, evaluate each radical. So there's a bunch of different kinds of roots. There's a square root. Okay, so even though it's not written, you should think of this as a 2 here, a square root. There's a cube root, there's a fourth root, and there's a fifth root. Okay. So the difference between each of these types of roots is how many identical factors we're looking for in the number underneath. Okay, so in part A, because it's a square root, we're looking for 2 identical factors. So what you should be thinking is that 144 is 12 times 12. So the square root is going to take that pair of factors and turn it into a single factor. So the square root of 144 is 12. Now, for the cube root of 64, we want to look for 3 identical factors sitting inside 64. This is maybe a little harder, especially if you don't have your perfect powers memorized. Okay, so one way to do this is to go through and just start at 0 and see if 0 times 0 times 0 is 64. It's not. Right? 1 times 1 times 1, nope, that's not 64. 2 times 2 times 2, that's 8. 3 times 3 times 3, that's 27. 4 times 4 times 4, that's 64. So we know that inside 64, we have 3 4s being multiplied. So the cube root is going to take those 3 identical factors and turn it into a single factor. So the cube root of 64 is 4. Again, it helps a great deal to have those perfect powers memorized, so you can just know as soon as you see 64 that it's 4 times 4 times 4. In part C, we're looking for the fourth root of 81. So the fourth root means we're looking for a group of 4 identical factors sitting inside 81. Okay, so 81, it's not 0 times 0 times 0 times 0. It's not 1 times 1 times 1 times 1. It's not 2 times 2 times 2 times 2 because that's 16. But 81 is 3 times 3 times 3 times 3. So the fourth root of 81 is going to take these 4 identical factors and turn it into a single factor. Okay. Finally, we have the fifth root of 1 divided by 32. So I would suggest breaking this up into the numerator and the denominator. Okay, think of this as, what 5 identical factors multiply out to 1? Well, that's 1 times 1 times 1 times 1 times 1. And what 5 identical factors multiply out to 32? Well, 2 times 2 times 2 times 2 times 2 is 32. So this fifth root is going to take the 5 identical factors of 1/2. So inside the 1 over 32, you have 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Right? Because 1 times 1 times 1 times 1 times 1 gives you 1, and 2 times 2 times 2 times 2 times 2 gives you 32. So the fifth root operation takes these 5 identical factors and spits out one of them. So the fifth root of 1 over 32 is 1/2. Okay, so here we are with example 2, same instructions, evaluate each radical. But example 2 is focusing on negative signs and square roots. So let's see if we can figure out what these negative signs mean, because each of them means something a little different. So in part A, the problem is asking you to evaluate the negative square root of 196. So basically, this negative on the outside is going to tag along and make your answer negative. Okay, so when the negative is outside the radical, it tags along and makes the answer negative. Now, we still have to evaluate the square root of 196. So we still have to look for two identical factors inside 196. And according to my perfect powers chart, which I have memorized, 196 is 14 times 14. So the square root is going to take that pair of identical factors and spit out a single factor, and then the negative sign tags along. So the negative square root of 196 is equal to negative 14. Okay, so what about part B? Notice the difference between part A and part B is that in part B the negative sign is underneath the radical. What that means is I now have to look for a pair of factors that multiply out to negative 196. Okay, so I know that 196 is 14 times 14. So if I'm looking for a pair of identical factors in negative 196, maybe I try negative 14 times negative 14. Does that work? No, negative 14 times negative 14 is positive 196. Okay, so that's a bad idea. What else can I do? Well, I can do positive 14 times positive 14, but I already know that that's positive 196 as well. So the idea here is there's no real number that when you multiply it by itself gives you negative 196. The only possibility would be 14 or negative 14. And both of those multiply out to positive 196. Okay, so this negative sign underneath the square root is a real troublemaker. Okay, when you have a negative underneath a square root, there is no real number that will work as the square root. So there is no real number that when you multiply by itself gives you negative 196. For the last part of this example, we have to consider the negative square root of negative 196. Now, you sort of want to think of this like an order of operations problem, right? This negative outside is multiplication. Okay, before you can multiply by this negative 1, right, before you can actually do that multiplication, you have to evaluate what the square root of negative 196 is. And as we just saw in the last problem, the square root of negative 196 is not a real number. What that means is the negative 1 outside doesn't matter. Okay, since the square root of negative 196 is not a real number, this negative 1 outside being multiplied doesn't even come into consideration. Okay. A critical error that students make is they try to multiply these two negative signs. You can't do that until you evaluate the radical first. This has a higher precedence in the order of operations. Radicals are like exponents. You have to evaluate this before you can move on to the multiplication. And since this doesn't make any sense, negative 1 times it still doesn't make any sense. I want to add in one more part to this example because as you see we've talked about negative signs in square roots, but we haven't talked about negative signs in other roots. So for example, if I wanted to evaluate the cube root of negative 8, what happens? Alright, so in this case, because it's a cube root, I'm looking for 3 identical factors inside of this negative 8. That's actually possible, right? Positive 8 is 2 times 2 times 2. So negative 8 is negative 2 times negative 2 times negative 2. Which means that the cube root is going to take these 3 identical factors and spit out a single factor. So the cube root of negative 8 is negative 2. So when you have odd roots, when you have roots with an odd number in the index, then the negative underneath is not a problem. It just makes the answer negative. When you have square roots or fourth roots, or roots with an even number as the index, the negative is going to cause you to get not a real number. Okay. This is when negatives are underneath the radical symbol. Negative outside the radical symbol doesn't matter. That always just tags along and changes your answer to a negative. Okay, so here's our third example. It should go a little bit quicker than the other ones. The point of this example is to teach you that 0 and 1 aren't really special when you're dealing with radicals. Okay, there's nothing bad about taking the square root of 0 or the cube root of 0. There's no problems. All right, so in part A of this example, if you want to evaluate the square root of 0, you just look for a number that when you multiply it by itself gives you 0. Right, you look for identical factors of 0. Well, 0 times 0 is 0. So the square root of 0 is 0. Right, the square root takes these identical factors and spits out just a single one of them. Same thing with the cube root. You would look for a group of 3 identical factors inside of 0. And you know that 0 times 0 times 0 is still 0. So the cube root is going to take these 3 identical factors and give you back 0. Okay. 1 behaves in a similar way. The square root of 1, we would have to look for 2 identical factors inside 1. Well, 1 is 1 times 1. So the square root of 1 is 1. Similarly, the cube root of 1 is 1. Right? Because if you look for 3 identical factors in 1, you see that 1 is 1 times 1 times 1. So the cube root of 1 is just 1. Okay, so 0 and 1 are fairly nice when you're taking roots.